Good morning. Today I'm gonna to explain about lab 10 Ohm's law. So here is a lab manual. Yeah, this is I'm gonna briefly explain about this. What do we need to do? So we yes, and in this case we have to check Ohm's law. What is Ohm's law? Ohm's law is simple. Just Ohm Ohm's law, Ohm's law. Ohm's law means, if we have some conductor here, then maybe we think that is resistance. Resistance. Change it. I have to change the color. Ohm's law is if we have some resistance here, and here is a current, electric current flow through here, and then we can see here we have some battery, and then voltage between terminals of the resistance resistor is like we think we. Then if we increase electric current, maybe electric current, then voltage also increase. That is, this relation like if we have current and voltage, this is I is current, electric current, electric current. What is the definition of that? Electric current is just the number of charge flow in through a cross section of a conductor maybe, or something like a resistor. But just the charges, yeah, just the electric charges, just number of charges, just electric charge per unit time, then we can write electric current can divide the charge. This is charge divided by time. That is time. Charge written in the unit of coulomb. Time written in just second. We can. This is called coulomb. Coulomb is the unit of charge, and this is the second. Then here is voltage. What is voltage? If we have linear, means that it should be written like IV is proportional. Then what is voltage? Voltage actually difference. Voltage difference. What is voltage difference? That is maybe V. Think that if we have some this to tell about the voltage difference, you have to think 2 points here, and the 2 points you have to think that this is voltage means I think some if a charge moved through here, this is 1 coulomb charge moved here to here, then how much work done by the electric field, that's called voltage. Sometimes that is something like delta U over Q. Delta U is potential difference, electric potential difference, difference between 2 points, two points. this kind of electric voltage difference. Then in this case, we know Ohm's law. What is Ohm's? Ohm's law is that is the voltage, the voltage difference between two terminals, two maybe poles of a resistor, maybe a conductor is proportional to the current that flow through the conductor. This maybe you can see different definition, but just a simple statement is the current is proportional to V. Like this statement, you have to see. We have to see just this linear statement. Then now come back to the our lab manual is like here. So we have to see like this. What do we need to do? Object to determine the mathematical relationship between current potential difference and resistance in a simple circuit. You know, here's resistance. Resistance means the resistance is just proportional coefficients of that. You can see here is resistance. In this case, proportional coefficient R is equal to V over I. Then that is called to resistance. Unit of resistance is 1 ohm. This is called ohm. Recently coronavirus Omicron is, I guess, derived from ohm. Omega. So like this ohm is a name of a physicist, French physicist, but unit of resistance is 1 ohm. Then we can write V equal to voltage equal to current times resistance. This kind of statement we have to check through this experiment. Okay, now we come back to our manual. It's like examine the potential versus current behavior of the resistor and current versus resistance for fixed potential, like that. Then we can see you can answer this question. If the voltage doubles, what happened to current? Voltage doubles also current also can be doubled, right? And then what type of relationship do you believe exists between voltage and current? That is linearly proportional, directly proportional. And with the voltage slider 4.5 moved, you can check that. I think we have to consider check open this phase simulator. Okay. Yeah, you have to see here. You can do this one. Then we're gonna see his procedure. Set the resistance. Let me show. Okay. Let me show. This is our simulator, and procedure is like this. Set the resistance slide is 300 ohms. You can move to 300 ohm. 300 ohm. 300 ohm. Really sensitive. How to have this keyboard. Adjust the slider, adjust the sample steps, that adjust large steps, jump into minimum. Smaller steps, shift, I guess shift, the arrow. That doesn't work. Why is it? Really hard to tune this age. I think this should be. Why is it they made that this way? Approximately 200. Yes, I think this is bad. Why? Usually it was, but the recent version is yeah, 299, approximately 300. And then what do we need to do? The next one is potential. Is current potential is 1.5. That is voltage. Voltage potential same or the 1.5, 1.5, 1.5. You have to see only potential 1.5. That's what happens. In that case, 5 milliampere. Then you can fill the data table. You have to see. Let's check this. Mm. Okay, so this one, as I showed, this, as I showed here, and this is 5 milliampere. We have to write here in the data table. 5 milliampere. Here is 5. 5. This is 300 ohm. We have to write here 300 ohm. Then what about 3 when we set the 3 volt? You can see here. 3 volt. Target 3 volt. 3 volt case 10 milliampere. We can see here, we can move to 10 milliampere. 10 milliampere. Oops. 10 milliampere. And you have to fill all the data by using there. And also, if I do 4.5, 4.5, 4.5, voltage set to 4.5. Then this should be this is exactly 300. How to get 300? How do we say? This should be very sensitive. Oh yeah, that is yeah. You can use a tab. Just select any button by using tab. You may use a tab. Yeah, tab is a good. Yeah, tab. Yeah, press tab. Then you can choose that. Is you can find exactly 300. 300 in this case 15 milliampere. 15 milliampere. Okay, 15 milliampere. 15 milliampere. 15 milliampere. Then we have to draw a graph, actual graph. Maybe here is if we do more, you can do yourself. Then we can draw a graph by using Excel. We have to see. Let me check here. Is it? So the Excel here is I is milliampere, milliampere, milliampere current, and then voltage just volt, and then as we showed here is when just in the table we think 5 milliampere case, 5 milliampere case, 5 milliampere case, you know, is 1.5, 1.5. Then 10 milliampere case, 10 milliampere case, 3. And then 15 milliampere case, 15 milliampere case, 4.5. Yeah. Then you have to draw this figure. Let me show. Let's draw this figure. How to draw that? We have to use the scattering, the insert, and after selecting this zone, and then we have to scatter one. You can see here is voltage. This horizontal is like this. X-axis should be current, y-axis should be voltage. That this kind of thing. We have to find the trend line. That is feeding. For feeding, we have to add a trend line. Trend line. That must be linear one. Then also important thing is you have to see displace equation on chart. Display equation on chart. Yeah, this is important. You have to choose this option, display, check this box, display equation on chart. In that case, you can see this equation. This equation is important. This 0.3 is the slope of this graph. Let me see. This is y equal to 0.3 x. That is the slope of this graph. Then copy this one into the here. Oops. So PowerPoint. Then here I used it here. Then this is a slope. Is this 0.3 is that is a slope. That we have added to use a trend line. Add a trend line. Yeah. Is that this is a slope 0.3. That means V equal to 0.3 I. But in this case, here is we have to consider because we use the milliampere unit. Then slope of case is 0.3. But slope times 1,000 because usually ohm is 1 volt per ampere, not milliampere. Milliampere case we have to see to compare this. If we use milliampere, 1 volt 1 milliampere case, 1 milliampere, 1000 milliampere, 1000 milliampere is equal to 1 ampere, because 1 ampere is equal to 1000 milliampere. Then we multiply the same one, 1000 milliampere, 1 ampere is exactly the same one, is numerator and denominator. By multiply there, the relation doesn't change. Then we know milliampere, check, cancel that is 1000 times 424 ampere. That is 1000 times something ohm. Ohm. That is, we have to 0.3 times 1000. That it means this resistance 300 ohm. That is consistent to what we said originally. That is, in this case, error is, this is that is theoretical value, theoretical value. This is experimental value. That is experimental value. In this case, this simulator is ideal simulator. Not the real case, not like Hanafa is experimental. Then we can error. How to get error? Error is equal to theoretical value, maybe experimental value, theoretical value, theoretical value over theoretical value minus experimental value, then times 100. In this case, theoretical value 300, that 300 minus experimental value 300, that 100 is 0% error. Yeah, there's no error, anything, just 0%. We can write it this way. And what about the data table 2? Data table 2. They can come back to our manual. This is what I explained here. And then we have this data table 2. That in this case, the resistance is, what is resistance? We set here to switch back to PET simulation. Resistance slide 600 ohm. 600. Use the voltage slider. Adjust potential to values data table. That's 600 ohm. Yeah, here. Then you can see. This is 600. Let me copy this one. Data table 2. What's this one? And then you can see here, copy this one. Table 2, data table 2. Data table 2, that is 600 ohm. We have to set 600 ohm. That we have the current voltage is also same, similarly change 1.5, 3, 4.5. Then we can come back to our simulator here. Simulator. Okay. Here is 600 ohm. How to 600 change? You have to use tab. Choose the button. This 600 ohm. 600 ohm. Then originally it was voltage is 1.5. Or this is also after here that tap. If I click that, and then if I press tap and tap key, then you can choose this selected. Then you can use arrow, down arrow, downside arrow. Then there you can upside downside arrow. Then you can find 1.5. In that case, you can see current is 2.5 milliampere. We can come back to data table. 2.5 milliampere. To 5.5 milliampere. And what about 3 volt case? 3 volt case. 3, 5 milliampere. 5 milliampere. What about 4.5? 7.5 milliampere. 7.5, 7.5 milliampere. Then by using this data, we can draw graph again, similarly. Then we have to draw slope of graph. Then yeah, then we have to use Excel. And maybe we can see I milliampere, V voltage, and then we have to see. First we used 1 point. We use the data table as 2.5, 7.5, 2.5, 7.5, 2.5, 2.5, 5, 7. You have to use all the data, but for me, just I choose only 3 values, first 3 values, because this is your experiment, not my lab. Yeah, but just I want to explain that. But you can do all the values, 6 values. You have to all the value field there. Then what about voltage? Voltage is like 1.5, 3, 1.5, 3, 1.5, 3, 4.5. Then now we're gonna draw graph again. We're gonna draw graph. Select this region, then insert just scatter one. That is exactly also linear. Then we have to add trend line again. Trend line. Then we have to choose a linear one here. Trend line options. We have to choose linear, and then we have to choose this. Check this box. Display equation on chart. Display equation on chart. So you can see here is a display equation on chart. This is as I said, this is related to slope. 0.6 is slope of this graph. So you can copy this graph. This one, then you can see here. That, as I said here, slope is 0.6. This is slope. This is a slope. Then 0.6. Then we can see here is 0.6. Slope is 0.6 voltage per milliampere. Then if multiply 0.6 times 1000, that we can find 600 ohm. That is exactly consistent with this value, theoretical value. That what must be, I think, error. Error is, as I said, error is like theoretical value are theoretical value. That's numerator must are theoretical value minus are experimental value times 100%. That in this case, theoretical value is 600. Numerator 600 minus 600 times 100%. That is error 0%. Must be 0%. We can come back to data table 3. How many table here? Data table 3. Analysis. Yeah, I can see 3. That 3 is the last one. Is data table 3. Switch back to the PET simulation return the voltage slider up to 4.5 volt. 4.5 volt. In this case, we have to see the IV graph. IV graph inverse B. IV graph. IV graph. I versus V graph. Yeah, have to draw it there. Bit constant is 1,000, maybe volt. You know, in this right x-axis, you know, what do you mean that is? Let me check data table 3. Have to copy data table 3. Let me share PowerPoint here. That is what I copied one, and you can see here. Yeah, data table 3. And here is, you know, the graph must be like x-axis is I, y-axis r. Then, you know, r over I over graph of inverse b, r over I, r ampere, ampere. Inverse b is constant, I over r. Maybe yeah, this, you know, r is like v over I. Then, you know, v times 1 over I, like that. That's, we think v must be constant, but I is maybe like this inverse b. Like inverse speed, we have to use inverse speed. What is inverse speed? We have to use not linear, but inverse speed. Inverse speed. Then, you know, r times r is equal to something like times 1 over I. This one, that is, that what is this one? This is a slope, maybe slope, inverse slope. Yeah, inverse, that bit constant, constant. That is, you know, if I think this one is rewrite I times R is equal to this bit constant. Bit constant must be unit is milliampere times ohm, right? We can write this way. And now we're gonna do experiment 2. As you see here, is voltage is 4.5 voltage. So you can come back to this one is 4.5 voltage. 4.5 voltage. Then what we just change resistance 100, 200, 300, 400, and we can choose only first 3 values. We're gonna come back to our simulator, base simulator. Then 4.5 voltage. 4.5 voltage. 4.5 voltage. 4.5 voltage. Then resistance is 100. We can choose here 100. 100. In that case, 45 milliampere. We can find 45 milliampere. 100 case, 45 milliampere. 45 milliampere. Then what about if 200 case? 200. Then 22.5 milliampere. 22.5 milliampere. 22.5 milliampere. What about 300 case? 300 case. 15 milliampere. 15 milliampere. 15 milliampere. Like that. I can see here. Then we have to draw graph again, and then we may use we have to use Excel again. Excel is okay, Excel. Let me have Excel. Axial is just x-axis should be R resistance R ohm. Y-axis is as you showed here. Y-axis current I is milliampere. Then we can we can copy the value. So 100, 200, 300, 45, 22.5, 100, 200. Maybe you have to use all six values, but for me I just use only first three values: 2.2, 5, 15. That is according to the data table, PowerPoint. Here is 45, 2.5, 15. Then we can come back to our Excel graph. Excel graph, and then we have to draw graph. Insert scatter line. If they're like this graph, then this should be, you have to add a trend line here. Add a trend line here. But if we use a linear line, it's very strange. In that case, we have to use inverse. Inverse case, we have to use just power. Power works well. Then power case. If I use a power, and this case we have to choose a power. Yeah, option trend line option. You have to choose a power. Then we have to choose display equation on chart. This we have to check this one. Then we can see here. This is what is shown here. This is 4,500 is a constant, just but x minus 1 power is exactly same to 1 over x. Yes, inverse, just reciprocal of a current there. I can copy this one. It's yeah, it's, yeah. Then we can analyze this data now. Here 4.5. This is the constant, feeding constant. This we have to use choose power. Trend line, and option. We should use not the linear, just power law here. Power law we have to use that. X inverse exactly same to 1 over x. It means y equal to 4,500 over x. Y is as I said, this y is just what is y? It has resistance. R is resistance. R ohm. X is just I milliampere. That means this is R equal to 4,500 divided by I milliampere, right? That is R is ohm. Then what do we need to get here? What do we need to here? Here is inverse feed constant 4,500. Yeah, here is the constant inverse feed constant 4,500. Feed constant divided by 1,000 is 4,500 divided by 1,000 can be 4.5 volt. This is exactly consistent with because in this case ideal simulator there is no error. So you can see bit constant divided by 1,000 with delta. If we click here to enter error, bit the constant divided by delta. Here is theoretical value. This is theoretical value. There. This is we can write delta v theoretical value. This is experimental value. Delta v experimental value. Then we can see error is delta v maybe theoretical experimental value minus delta v theoretical value divided by delta V theoretical value times 100. This is error bar. In this case, delta V experimental value is 4.5. Then theoretical value also 4.5 divided by 4.5 times 100. Yeah, error must be 0% error. That is 0% error. That's all. Yeah, and that's it. Yeah, you can do by yourself the rest part of experiment. So thank you for watching this video. And I'm gonna close. Maybe you can do yourself the rest of things. Okay, I will upload this PowerPoint to announcement. Okay.